native to the area, which means he knows all about the Blues Brothers. He's got a Bachelor of Science in Electrical Engineering way back in 1979, and then he also got a degree from the Illinois Institute of Technology in Chicago. He's done a lot of hardware and software for about 25 years total. He's worked for companies like Motorola, Honeywell, Rockwell. He's now doing software consulting, does custom C language embedded systems on computers. But his real passion is what you're going to see next, which is free energy and anti-gravity research. Here's William Alek.
Okay. Thank you, Terry. Okay, can you hear me? Okay. Okay. I first got interested in anti-gravity and free energy back in 1998. Attended a Richard Hoagland and the Tom Bearden conference. And at that time, I was just totally hooked on it. So I wanted to read everything I could possibly read in this field. So what I'm going to present today is my latest research.
I'm going to move this up a little bit more soft-spoken.
Yeah, there we go. Okay, what is free energy and anti-gravity? Seems to be the greatest puzzle today. Are they related? Well, the short answer is yes. Okay, and we begin our journey with relativity theory, because it turns out that these devices are relativistic. But what happened is that relativity theory does not predict free energy or anti-gravity. And I asked the question, well, why? So I asked the question, did Einstein get it right or not? Einstein's GR theory used F equals ma, okay, which is Newton's second law, and Newton's gravitational force, F equals mg. And what Einstein did in 1916 is that he equates these two equations. Okay, is this concept correct? So what Einstein did is that he formed his equivalence principle by equating those two equations, okay? And he stated there is no experiment a person could conduct in a small space or a small volume of space that would distinguish between a gravitational field and an equivalent uniform acceleration. And I question that. Is that so? So Einstein's thought experiment, you know, the classic elevator problem, okay, where he shows, okay, an elevator at rest on the Earth and an elevator accelerating in distant space, okay, without any kind of gravitational influence. And it turns out that this relationship is not equivalent. Let's go back to the, well, why isn't this equivalent? Well, because when you start to analyze a mass in motion, and in this case is accelerating in space, this mass is actually changing, whereas a mass at rest on the Earth isn't changing at all. So now we have this perhaps proof that Einstein's equivalence principle isn't true at all. So then what is this new equivalence principle? Okay, because I think there's an equivalence. And it turns out that a body in free fall, okay, in the elevator, falling a given distance is equivalent to some body that's moving in free space. Okay, and what we see here is that the change of mass for both these conditions here are the same. So with this theory here is that we see a new equivalence principle. So given that information, I then looked at Einstein's, I believe it's his 1905 paper on special relativity, and I used a simplified version of his calculations of the Lorentz transform, and I come up with this equation up here, okay? And what this shows is that a mass being accelerated in free space, okay, its its mass will diverge to infinity as you approach the speed of light. And then I asked the question, is that, well, what would happen if this velocity turned out to be an imaginary velocity? Well, it turns out that when you do the calculations, this mass will drop to zero or perhaps become a negative mass. Well, I thought that was very interesting because you don't ever see this left-hand side in any of Einstein's work. And it turns out that what they would do is put absolute value symbols around this, and they would essentially eliminate.
Use that pointer, that one shows up in the video, the other one doesn't.
Okay. Okay. So Einstein's left-hand side here doesn't show up at all. So it turns out that, well, you apply this to Einstein's 1916 paper, and you find out that Einstein only predicts gravity. Okay, but what we're interested in here is anti-gravitational effects. So all I had to do was just include this imaginary component, and all of a sudden I get this negative mass component. Okay, then I applied this new equivalence theory that I came up with, and I came up with this equation here. Yep. Right here. And you'll notice that these two equations, they're both e to the power of, let me go back to that original equation. Okay. Yeah, both these equations here, they both are exponential functions. And that's very interesting because you can almost model a changing mass as like a charging capacitor. So instead of a capacitor charging with electrical energy, here it's charging with mass. Now, I thought that was very interesting. So then when I applied this equivalence principle, I have this relationship over here of distance falling in a gravity well, okay, is equivalent to some mass moving at some constant velocity in deep space. Okay, so you have distance related to a velocity. And you'll also notice that with this gravitational redshift, okay, what I call a redshift here, is that the mass will increase as it approaches the surface of the Earth, for example. So we have this gravitational redshift, but if you look at it from decreasing gravity, you observe a gravitational blue shift.
Please use this one. That one doesn't show up on the video.
Okay. Okay. Okay, so working with this equivalence principle, I came up with this equation here of how I relate this distance falling in a gravity well to a velocity. And it turns out that when you run the numbers on this, if the velocity is real, okay, you have a positive displacement, and you can call that gravity. Okay, if the velocity is imaginary, then this displacement is negative or anti-gravitational. Okay, so that's a key component, I think, when working with anti-gravity. So then I applied this to Newton's gravity equation. I say given over here. And that when a mass falls in a gravity field, okay, we see this increase in mass. And we say that it's gravitationally redshifting, okay, with this positive displacement. For anti-gravity, okay, we have this gravitational blue shift, okay, where the mass is decreasing. So then, you know, I applied this theory to, let's say, the electromagnetic spectrum. And so what I discovered here is that for light, we see how light behaves in a gravitational field, where if light is approaching the Earth, well, it's gonna increase in frequency, increase in energy, so we're gonna see this blue shift. Okay, if light is leaving the Earth, well, we're gonna see a gravitational red shift. Okay, and this is actually proven. Okay, this experiment is actually proven, okay, by the Pound-Rebka-Snyder experiments. And also recently with some GPS calculations that I ran. So then I tested this theory using this GPS satellite data. And when I ran the numbers, I was rather astonished by this, because the answer that I came up with, okay, is slightly more accurate than Einstein's GR theory. Okay, and I got this on my website, so you can actually check the numbers and see these results. So I knew this theory, how light is affected by the motion of a satellite and how it passes through a gravity field. It looks like my theory is fairly correct here. So then I picked up a paper by Paul Marmot. He's a Canadian professor. And he wrote this paper that used the Biot-Savart law, okay, for magnetic induction. And this is taught in every electrical engineering course. And what it is just an electron flow, or perhaps a positive current flow, okay, will produce this magnetic field. Now it turns out that when I started analyzing this, looking at Marmot's work, I noticed that this Biot-Savart law, okay, is a relativistic equation. And it's correlated to the motion of electrons, perhaps on a wire, okay, producing this magnetic field. And it turns out that when you equate this, okay, to the energy, E equals mc squared, okay, you end up with these equations here. And it turns out that this magnetic component, the energy in this magnetic field, okay, turns out to be the relativistic mass increase of these electrons in motion. So that told me that the mass of an electron is constant, but as this electron moves faster and faster, the field energy, okay, contained this increase in mass. So you can actually represent this, this magnetic field, okay, around this electron here as mass, okay? And again, that explains why mass has momentum, okay, because you can express that as mass. Okay, so then I applied this to my theory here of this equivalence principle, and I came up with these equations here. Okay. And then I came up with this very interesting equation right here, okay, that relates this change of mass of an electron, which of course is this magnetic field. If that changes, if there's a negative change, that means that the velocity of that electron is imaginary, okay? If the mass increase is positive, all right, well, you're gonna have a real component, it's gonna have a real velocity. And then coupling this with my equivalence principle, this imaginary velocity, okay, means that the system will couple anti-gravitic. Okay, and then with the positive real velocity, you're going to have a gravitic action there. Okay, and then this is just a repeat of the chart here, showing that with this imaginary velocity, okay, we have this decrease in mass. And let's see. Okay. And I just show that in the calculations here, applying this to this equivalence principle, you know, how I work through these equations, how this couples to gravity. And then equation here, okay, and when you evaluate this, then you get this red shifting and blue shifting of the same mass. So then this led me to question, well, what is the nature of the ether then? You know, what part does the ether play in all this? Because the question that I had to answer is, well, where's all this excess mass coming from? Okay, that would form in this magnetic field. Okay, well, where's this mass coming from? Well, there's really only one place, and that would have to be the ether. So I'm saying that the reservoir, that the ether is really a reservoir of uncondensed mass. So that as the particle moves in space or it falls in a gravity field, this uncondensed mass will condense onto matter, okay, giving us essentially these two relativities here, okay, with gravity. So this will also affect the ether density, okay, around this particle. So then we have a correlation between this increase in mass and the change in the ether density. And I think that's a one-to-one relationship. So then I go on to say that, well, the ether really isn't capable of absorbing or emitting heat. Therefore, it doesn't really have a temperature at all. So what gives space temperature is really the presence of electromagnetic energy. Okay. So then a perfect insulator in terms of DC resistance, the ether would have infinite resistance. Okay, and it limits the propagation of light and the energy of light, okay, as a function of ether density. So if we change the ether density, okay, we change the energy of light that passes through or propagates through. So then I looked at the AB effect. And what I think is going on here is that we have electrons, you know, passing through these two slits, and they set up this interference pattern as they pass by a coil, very long coil. And what the field is outside this is the real field is essentially zero. But what I think might be present is this imaginary field. Okay, if the particle is moving or is being acted upon by an imaginary magnetic field or electric field. Okay, it's going to show up as a temporal effect. So essentially, I can perhaps upgrade the Maxwell equations to include this mass component, okay, to show a temporal effect. So then there's been a lot of talk about negative resistance, you know, quantum tunneling. You know, does negative existence or resistance really exist? And I'm saying that it's essentially a myth. Okay, negative resistance. So what you have instead is a particle, an electron, okay, that can either move with the real velocity or an imaginary velocity. And this imaginary velocity would have an associated imaginary electric and magnetic field. So I'm saying that negative resistance can be reinterpreted as a complex current flow. And this complex current flow, I give it a how it would evaluate as a temporal rotation. So then the current flowing through a circuit, this current here can be complex. Okay. So what I'm really saying with this complex flow is that the electron flow has a temporal component added on to it. Okay, and this resistor over here, okay, with a real current and no complex component, it's going to dissipate heat. Okay, but with a complex imaginary flow, okay, the resistor is going to absorb heat. Okay, the resistor is going to get cold. Now, I found that out by doing all these calculations. So then I extended this model into what I would call free energy systems. And I came up with this design here of a four-terminal device where your source dipole into a complex field generator. The source dipole, you feed it a real energy flow. And the output of this device is going to have this complex current. associated with it. So you're going to have a complex current flow. Okay, perhaps charging up a load dipole or another battery. So in a two-terminal system, what you're going to have is the load source battery here, and you input your real flow here, and you output a complex flow here with this type of a system. So here you would observe some anti-gravitational effects, since we have an active imaginary flow here. Okay, we're essentially changing the mass of the system, and that mass can be either very positive or negative, so you can have an anti-gravitational system or a gravitational system. And we would also expect to see temporal effects with this phenomena. And that led me to this device here that I call the Z-Pod. And the Z-Pod is nothing more than a collection of these coils that I switch on and off. And this system here is based on a Russian paper published in Alek New Energy Technology magazines from a few years back, and I decided to replicate this project because the researcher, Nikolai Zayev, was his name, observed excess energy, okay, from this system. So I began experimenting a couple of years back with this. Here's another photo. And this is what I observed. This is on the secondary side. What's interesting about this is that this part, just before this transient occurs, is charging a capacitor. And then what I do on the secondary side is essentially short the secondary side. But I observe this decay here that's much longer than what I charged that original voltage with. And then I see this big transient that occurs between magnetizing and demagnetizing these coils. So I suspect what's going on here is that as soon as I switch off activating this system, we have a change of permeability in the system. And so the energy that exists within the system is being amplified by this change of permeability. So in a way, I mean, you can almost relate this to a kind of a Casimir effect that's occurring magnetically within this magnetic media here. So then here's another picture. This is just a simplified Z-pod design. Okay, and what was shown graphically on the previous page there, I show over here, a typical transformer, you probably see something like this. Okay, the energy you put in equals the energy you get out. With the Z-pod, now I'm still evaluating this system. Okay, so you know, I still don't know if this is true yet. If the device is really putting out this excess energy. I think it is. Okay, but there's more testing I still have to do on this device. So then just subtracting these two, the area under the circle between these two, I think this is what the excess energy would be. Okay. So then I started looking at some applications. I was contacted by another researcher down in St. Louis. We came up with this device here called the e-bike. It's commercially available. I'm not sure if it's commercially available anymore, but we had adapted my controller to this bike. So here's another photo here. There's a smart pack system there. This was, of course, before the Z-pod came along. So the smart pack system that I came up with is really just a test platform. So the idea is that you can take what I call these pods, or just magnetic devices, plug them in and test them. And when I came up with the Z-pod, well, pretty much ideal for this test platform, so I just plug that in later on. So then I started looking at Tesla's work. And what I think a lot of people have missed when analyzing Tesla's systems are his generators. And he spent 10 years developing these. Started back in the 1890s, and it's based off of observations that Tesla made back in the 1850s, 60s, and 70s, and he came up with this design. And what this shows, when you analyze his generator, okay, he shows a DC motor where the flux runs in one direction, okay, and you have this counter flux running in another direction, okay? And for a long time, I was trying to figure out what this guy's doing. And I then started applying to my current theory, and I noticed that what I think he's doing is generating this imaginary complex current in his systems. So he puts real energy in and gets this complex current coming out. Now, it turns out that when you do these calculations, you find out that when you work with a complex current, you can have negative power and negative energy in your circuit. And that's what I think Tesla was working with. Okay, complex fields. So then this is just another analysis here of what I think Tesla was doing. So then this brings up another inventor by the name of John Hutchison. And I think that, you know, applying all this theory that I've been developing, I think I have an explanation for the Hutchison effect and his cold melting of metals. Because John did not apply any heat, okay, to these metal samples, and he just melted it. You know, how is that possible? So here's a few of his samples here, and his sample up here, I believe, has a piece of organic material embedded in a block, okay, which is just an extraordinary sample. You know, how did he possibly do this? Okay, without destroying the organic material. So then I applied this complex generator, okay, Tesla's generator. Okay, to this metal sample. And what I reasoned is that, okay, you had this complex current flowing through this system. Complex current is going to create a complex magnetic field. And this complex magnetic field, when it sees this block of metal, is going to set up eddy currents. And so I figured that, you know, since power can be negative, energy can be negative, okay, these eddy currents are cold. So what you have here is perhaps the beginning, okay, of a revolution in metallurgy. Okay, and that's the cold melting of metals with an explanation of using complex fields. Okay, and then with my gravity theory, you know, I'm constantly coming up with ideas on how to test the theory. Because the idea is that you want to maybe perhaps perform a few experiments, and then, you know, I'm probably more of a theory guy, so I like physics. So the idea is then to develop a theory and then test the theory with experiments, okay, to prove the theory out. So then I started looking at what are called these gravitational mystery spots. And the question, well, are these places for real? Because they're essentially tourist traps. So then I toured one over there in Santa Cruz, and I found out that, man, this place is for real. Because what you see in this phenomena is what they call shrink growth phenomena. And what you actually see is that they place two people face to face, and then you switch positions, and what you see is a height change. Okay, and which I thought was just absolutely extraordinary. But what you do is that they have several of these tight demonstrations scattered around the site, and what you can do with that is build an image of what this gravity anomaly actually looks like. So then I came up with this picture that, well, this phenomena looks like a toroid. Okay? And they have this other demonstration in there, which is absolutely extraordinary, which is the pendulum demonstration. And this pendulum is placed across a sharp gravity gradient. And when you push on this pendulum, it's easier to push in one direction than the other. I mean, you can actually feel it. Then as the pendulum swings back and forth, you can actually hear that it's that the pendulum is lighter here and heavier over here. So that means that the weight of the pendulum is actually changing, which is just extraordinary, okay, in this phenomena here. And then a third effect is that the pendulum will start to precess. As it swings back and forth, it'll start to rotate. And this rotate, it'll rotate in one direction, okay, and And based on the direction of this gravity gradient, it'll start to rotate in the other direction. Okay, when it reaches a certain point there. Now also, there was a one of the tourist guides that worked at the Oregon vortex. Okay, and Nick Nelson, he wrote a book, and he mentioned that there was a time difference, okay, between inside the phenomena and outside the phenomena. And he said that this time would essentially slow down a watch. Okay, so then I started conducting some experiments, and I found out that gravity increases as you walk into this spot. So you have a gravitational redshift that occurs, because then you can actually see that this frequency start to shift as you walk into the phenomena. So then I went ahead and developed this equipment that measures this time shift. I came up with this data over here, okay, which shows a gravitational redshift, okay, as I walk the watch into the phenomena, okay, started to slow down. And then I reversed the experiment, and then I observed a gravitational blue shift, okay, as I walked the watch outside of the phenomena. So I thought that was pretty neat. So then I started working on the second generation, and that's what I have right now. I have this on display on a table. Okay, and that's this second generation device here. Yeah, it was Richard Hoagland that recommended using an Accutron watch in this project. So then this gave me an opportunity to apply my gravity theory, okay, to a gravitational mass. So then I wrote down all these equations, and what I'm looking for is a way of measuring this height change. Okay, because as you walk into this phenomena, if you bring in, if you brought in a ruler or a yardstick or a meter, okay, that yardstick is going to shrink with you as you walk into the phenomena. So you can't really measure it spatially. So what I'm doing here is measuring height changes with a frequency shift, with time. So using my equations, I can calculate what the height change is, okay, what the mass change is, okay, and then I display this temporal difference. And this is the software that runs on a notebook computer. The boxes, they plug in through a cable to a back of this notebook computer. And this is the software that I wrote, okay, that performs these calculations in real time. So here it shows the frequency variations of the boxes. Okay, the height change over here, the mass change. Okay, and the time difference. Then there's also a few other parameters that I calculate over here. And this is just an overall pictorial of this kit that I put together. And it shows the Accutron watch, some cabling, okay, to a precision clock that measures this watch. Here's 150 feet of cable, and this, and another box. Okay, and you all plug into the back of this portable computer. And so that brings me to analyzing this pendulum motion, you know, at this mystery spot. So I found out that this is a pendulum at the Museum of Science and Industry in Chicago. And here you have a Foucault pendulum with a nice steady gravity field. Okay, as it swings back and forth, the Earth rotates under the pendulum. But a pendulum at the mystery spot doesn't behave the same as a Foucault pendulum in Chicago. Okay, you have this non-uniform gravitational field acting on this pendulum that's in motion. So you're going to end up with two different force vectors. And so that brings me to an open source network. Tim's work, American Anti-Gravity, and I published some information on Tim's site. Also published some information on Gary Watts' Tap 10 site. that concludes my presentation.
Thank you.